Another example from the beginning. A pharmaceutical company has developed a diet pill called Effective Anti-Hunger Tablet, which the company believes will significantly reduce an individual's weight at the end of 1 week. To support the claim, the company selects 30 overweight people and randomly divides them into 2 independent groups. The treatment group of 15 subjects who administered the diet pill EAT, and the control group of 15 subjects who are given a placebo tablet that has no effect on weight. So 30 got divided into 2 different samples, 15 and 15. So sample size 1 is 15 and sample size 2 is 15. Sample size 1 got the diet pill, sample size 2 got the placebo. After 1 week, the treatment group had a sample mean weight loss of 7.1 pounds and a standard deviation of 3.6 pounds. And the control group had a sample mean weight loss of 4.2 pounds and a sample standard deviation of 2.3 pounds. Can the company conclude that their diet pill EAT will significantly reduce an individual's weight within 1 week at alpha equal 5%? We have to note what mu1 and mu2 are. So mu1 is the treatment group and mu2 is the control group. So noting that mu1 is the treatment group and mu2 is the control group is important, and we have to be consistent with that all the way through to the part where we use our calculator. The null hypothesis is going to state that there is no difference. There is no difference between the population mean weight loss for the treatment group and the control group. Okay, so you're always going to begin with the words, there is no difference between the population mean, and then you'll state what the 2 groups are. So in the last problem, it was Southern brides and Northern brides. In this problem, it's weight loss for the treatment group and the control group. And symbolically, we're going to state that mu sub 1 minus mu sub 2 equals 0. No difference. Alternative hypothesis is that the population mean weight loss for the treatment group is greater than the population mean loss for the control group. Okay, because weight loss, we would hope that this new pill increases weight loss, and so we would hope that when we looked at the mean weight loss for the treatment group, the people that got the pill, it's greater than that of the control group. So meaning that if we subtract treatment group minus control group, we'll have a number that's greater than 0, positive. Okay, so if we want mu1 to be greater than mu2, then we state our alternative hypothesis is mu sub 1 minus mu sub 2 is greater than 0. The 2 population standard deviations are not given, and so for that reason we're going to be using the t-distribution. Okay, so the population standard deviations for the 2 populations are not given, so we're going to be using the t-distribution. And that's always going to be the case with this kind of test. Since we have an alternative hypothesis that is trying to show that the population mean weight for the treatment group is significantly more than the population mean weight loss for the control group, we want to show mu1 minus mu2 greater than 0. The test is going to be on the right. Okay, so we are trying to show that mu1 minus mu2 is greater than 0, or mu1 is greater than mu2, and therefore the test is going to be on the right. And that's going to help us come up with the visual image for the decision rule. Oh, I did not state the mean of the sampling distribution. Okay, we will come back to the mean of the sampling distribution. Let's go forward with the decision rule. Formulating the decision rule. In the center, we're going to state the mean of the sampling distribution. So on your handout where it says mean of the sampling distribution and its correct symbol, you can put mu sub x bar 1 minus x bar 2 equals 0. This is a test on the right, so you're going to shade in the tail on the right side, and you're going to label that shaded area as 5%. You're going to specify the reject region and the fail to reject region. The decision rule is going to be to reject the null hypothesis at alpha equal 5% if the p-value of the sample statistic is less than or equal to 0.05. So this decision rule doesn't change from the last decision rule. You always want a p-value that's small, so you want your p-value to be smaller than alpha. The p-value is going to be the area that goes from the test statistic all the way up to positive infinity. The smaller the p-value, the further that test statistic is away from the center. And that's ideally what you want to show that there is a significant difference. So you always want a p-value less than or equal to alpha, even if your test is a greater than test. Looking at the sample data, x bar 1 minus x bar 2 is the symbol. So you're going to write the symbol x bar 1 minus x bar 2, and the value for x bar 1 minus x bar 2, you're going to take the two values, 7.1 and 4.2, subtract them, and get 2.9. If you locate where 2.9 is on the t-distribution, it's positive, and so it's on the right side of 0. Okay, so you've got your mean of the sampling distribution in the center at 0, and you've got your x bar 1 minus x bar 2 all the way on the right at 2.9. And when we find the p-value, it will be the area that goes from this point all the way to positive infinity. So the p-value of x bar 1 minus x bar 2 equals 2.9 will be the area to the right of 2.9. So going to the calculator, we'll find the p-value of the sample statistic. We're going to go to the calculator's two-sample t-test again. Make sure you highlight stats at the top. And for x bar 1, you're going to put the treatment group, 7.1. And the treatment group mean is 7.1. The treatment group standard deviation is 3.6. And the treatment group size, 15. Okay, remember that initial 30 got divided into two groups. And then x bar 2 is 4.2, sx2 is 2.3, and n2 is also 15. Scrolling down, make sure that you choose the direction as a greater than test, so greater than mu2. Down at pooled, you're going to press yes, and then calculate. And you've got a p-value of 0.0069. 0.0069. Okay, so that gives us enough information to come to a conclusion. Our p-value is 0.0069. That is smaller than alpha, and so we're going to be able to reject the null hypothesis. So if we compare alpha and the p-value, alpha is 5%, our p-value came out smaller than 1%. So it's definitely smaller and it fits inside alpha, and it indicates therefore that 2.9 is in the reject region. Okay, it's in the region where we can reject the null hypothesis, and it's very significant because it's smaller than 1%. So our conclusion is to reject HO and accept HA at alpha equal 5%. And we have to ask the question now, can the company conclude that their diet pill EAT will significantly reduce an individual's weight within 1 week? Well, when we rejected the null hypothesis, we rejected the claim that the two sample means, or rather that the two populations, those who took the weight loss pill and those who didn't take the weight loss pill, were the same. We've rejected that they're the same. We're accepting the claim that they have to be significantly different, in which case the diet pill will work. So we say yes, the diet pill EAT significantly reduces an individual's weight at the end of 1 week. So when you reject the null hypothesis, you reject that the two populations have the same mean. You reject that there is no difference between the placebo and the diet pill. Our test has proven that the two populations have significantly different means. Okay, so when we reject the null hypothesis, we reject that the difference is 0, and we accept that there's a significant difference between the two population means.